Hello, Year 10. I'm just going to go through the answers to this Year 10 quick topics recap quiz that's on Socrative. By the way, it's really good to see some of you in school and teach you face to face. I'm really enjoying it, and I hope to see you again soon. Right, question 1. A skydiver is falling at a terminal velocity. He has not yet opened his parachute. He opens his parachute. What is the direction of both velocity and skydiver? So what's happening in terms of the motion here is that they're falling, okay? So the velocity is downwards. And he's falling at a terminal velocity. It's a constant velocity because the forces are balanced. When he opens his parachute, there's a bigger force upwards. And if the force is upwards, the acceleration is upwards as well. Okay, because F equals ma. So the answer is the velocity is downwards and the acceleration is upwards because he's slowing down. So that's C. Question 2. A car is driving around a circular track at a constant speed. Which statement describes the motion of the car? When something's going round in a circle, it's constantly changing direction because it keeps turning. So even though it's going at a constant speed, the direction is changing. Now, what we know about acceleration is it's the rate of change of velocity. If it's going in a circle, the velocity is changing because velocity is speed with a direction. Yeah, so it's going at a constant speed, but the direction is constantly changing. So the velocity is changing. Okay, so for question 2, it's accelerating because the velocity is changing, and that's because the direction is changing. So it's C. When an object moves in a straight line, which statement is true? Okay. So A says when the object moves at constant speed, the resultant force is 0. Well, that's true. Let's have a look at the others, though. When an object accelerates, the resultant force is 0. No, F equals ma. It has to have a force. C, when an object moves at a constant speed, the forward force is greater than the resistive force. That's not true either, is it? Because if the forward force is greater, then there's going to be a resultant force forwards and it wouldn't be going at a constant speed. An object requires a resultant force in order to move at a constant speed. No, there can be no forces on an object and it will move at a constant speed. So the answer for 3 is A. Question 4. A motorbike travels at a constant speed along a flat road. 3 horizontal forces act. 2 of them are shown. What's the size of the other force? Well, if it's going at a constant speed, it's got balanced forces. So the forwards force must equal the backwards force. At the moment, it's got 2,000 newtons forwards and 800 backwards. So it needs an additional 1,200 newtons backwards, which is B. That's number 4 is B. Okay, question 5. We've got moments here. The diagram shows a door handle with 3 forces on it. What will happen how will it move? The 5 newtons pointing towards the pivot won't have a turning effect at all because it's not at an angle. The one that's 5 newtons furthest away from the pivot will have the greatest turning effect, okay? And the one that's nearer the pivot will have a smaller turning effect. So the answer will be it will turn clockwise. Okay, so the answer to 5 is A. Question 6. The graph shows a speed time graph of a cyclist who is moving in a straight line. What is the acceleration of the cyclist at a time of 20 seconds? So we're looking at this section of the graph here. Okay, now what we know about a speed time graph or a velocity time graph is the gradient of the graph is the acceleration. Yeah, because velocity and speed is the change in acceleration per unit time. And at 20 seconds, there isn't a change, it's flat. Yeah, the gradient is 0. So the answer to what's the acceleration at 20 seconds is also 0 because the gradient is 0. So 6 is C. Question 7. 2 cars are in a race. The graph shows the speed as it changes with time. What can be said about the motion of the 2 cars at time t? So it says they have both travelled the same distance. Well, that's not true, because for a speed time graph or a velocity time graph, the distance travelled is the area under the graph, and you can see that the dotted one will have a bigger area than the curved one underneath the graph. So it's not A. Their acceleration is the same. Well, acceleration, as I've just said, is the gradient, or the gradient here is steeper than here. So car A would have a greater acceleration. And C, car 1 is overtaking car 2. No, not necessarily. And D, both cars are travelling at the same speed. Well, if you look at that point, they meet, so they must be travelling at the same speed. So 7 is D. Question 8, we've got resistance. Now, you can't see it very well here, but that is 5.0 ohms, and that's 10 ohms, and that's 2.0 amps. I know this because I've worked it out both ways, and one way the answers don't appear. So the current through the top resistor is 2 amps. What is the reading on the ammeter? Well, if that's 10 ohms and that's 2 amps, and this is 5 ohms, this has half the resistance of that. If this has half the resistance, it should have double the current. So the current here should be 4 amps. If that's 2 and that's 4, that must be 6. So the answer to question 8 is A, 6 amps. A bookshop owner sets up a circuit below, but they find the lamp is too dim. What change can be made to the circuit to increase the brightness? Well, to increase the brightness of the bulb, we want more current. Okay, so we're looking at how can we make more current? Putting another resistor in parallel with a battery, well, that would just bypass that. Putting a resistor in parallel with the bulb, that would bypass that current. Some current would go through the resistors, the bulb would be dimmer. Putting another resistor in series with the resistor, if we put a resistor here, that makes the overall current in the circuit lower, so that's not right. Putting another resistor in parallel here. Now, when you've got resistors in parallel, remember the total resistance is smaller than any of the single resistors. Okay, and if the resistance is smaller, the current is bigger. Okay, so the answer to 9 is D. Question 10. Which of the diagrams below shows a fuse which has been correctly connected? The fuse has to go with the live wire. Okay, so it's not that one. You don't want it there, halfway across. Certainly don't want it in parallel with a switch. So D is the right answer, because the fuse wire is right in the live wire. Okay. Right, question 11. Okay. A small metal block is suspended in the surface of a beaker. It experiences pressure. What would increase the pressure exerted on the metal block? Increasing the surface area of the stone. Well, that would make the pressure less, because P equals F over A. A smaller density of liquid would be less pressure. Okay. Because there's fewer particles per volume. Increasing the mass of the metal block wouldn't really have any effect. And lowering the metal block deeper into the liquid would definitely increase the pressure. So 11 is D. Question 12. 3 ohm resistor is connected to a 15 volt supply. Okay, so this is quite a long question. Okay, and it tells you the ammeter reads 5 amps throughout the experiment. Okay, fantastic. So how much energy is dissipated by heat by the resistor in 2 minutes? So the energy equation in electricity is QV, charge times voltage, or charge times potential difference. Have we got charge? No, we haven't. But we have got the current, which is 5 amps, and 2 minutes. And current is, charge is current times time. So it's 5 amps times the time, but the time has to be in seconds. So it's 5 times 120, which is 600 coulombs. So now we're okay. Energy is Q times V. Energy is charge times potential difference. So we've got 600 coulombs times the battery potential difference, which is 15. So it's 600 times 15, which is 9,000 joules, which is A. Question 13. A cheesemonger uses a Newton meter to measure the weight of the block. So we've got the weight is 5 newtons. What's the mass? Well, if the gravitational field strength is 10, mass is weight divided by gravitational field strength. So it's 5 divided by 10. So 13. The answer is B. And lastly, a student is trying to measure some volume of liquid. The liquid will fit into 2 cylinders, but there's a large one and there's a small one. How would they get the most accurate result, and where would they measure the level from? Well, always, if you've got something you want to measure accurately, you would use the smaller container because the gradations on the actual scale, if it's a smaller measuring cylinder, it would push the liquid up and down much more sensitively. So it would definitely be the small measuring cylinder, and it would be the top of the meniscus, which is C. And there you go. So I'll just read them out again. 1 is C, 2 is C, 3 is A, 4 is B, 5 is A, 6 is C, 7 is D, 8A, 9D, 10D, 11D, 12A, 13B, 14C. Thank you very much. See you soon.